Welcome to our Quantum Deep Dive, an explainer based on the work of Jörg O. Schneppet. Today, we are talking about a true giant of physics, John Bardeen, and his incredible story.
So let me start with a question for you. How many Nobel Prizes in physics can a single person actually win in their lifetime?
Well, the answer is 2. And the person we're talking about today, John Bardeen, is the only physicist in history to ever pull it off. But what's really amazing is that he won for 2 discoveries that seem worlds apart, but which actually built the 2 essential pillars of our modern technological world.
Okay, let's dive right into his first monumental achievement. To do that, we have to go back to 1945, to the legendary Bell Telephone Laboratories. At the time, the world of electronics was powerful, for sure, but it was also incredibly clunky and unreliable. The big problem, the real bottleneck, was the vacuum tube. You have to picture these things. They were these fragile, power-hungry glass bulbs that generated a ton of heat. The mission for Bardeen and his colleagues, William Shockley and Walter Brattain, was to find a better way, a solid-state solution to control electricity without all that extra baggage.
And what they came up with was the point-contact transistor. Now, the definition here seems simple enough, but its implication was absolutely profound. For the very first time, they could precisely control the flow of electricity through a solid material. This meant electronics could finally be small, cool to the touch, and incredibly robust. It was, quite literally, the switch that flipped the entire world into the digital age.
And the speed of this change was just astonishing. I mean, think about it. From a first demonstration in 1947 to a Nobel Prize in less than 10 years is almost unheard of. But that was just the start. This single invention made integrated circuits possible, which in turn gave us the microprocessor. Every single digital device we use today, your phone, your laptop, it all traces its DNA right back to that moment at Bell Labs.
So you would think inventing the transistor would be the peak of anyone's career, right? I mean, you've just changed the world. But for Bardeen, that was just peak 1. In 1951, he moves to the University of Illinois and completely pivots from world-changing technology back to a deep, baffling mystery in fundamental physics.
And this was the central question that had stumped the world's greatest scientists for decades. The phenomenon of superconductivity, where certain materials lose all electrical resistance at super low temperatures, was discovered way back in 1911. It was like magic. You could start a current and it would just flow forever without losing any energy. But no one had any idea why it happened. So Bardeen teamed up with 2 brilliant new collaborators, Leon Cooper and Robert Schrieffer, and they set out to do what no one else could, to create the first complete microscopic theory to explain this absolutely bizarre quantum behavior from the ground up. Their incredible breakthrough came from this beautiful concept, Cooper pairs. Now, normally electrons with their negative charges should repel each other, but they figured out that in the ultra-cold, quiet world of a superconductor, an electron moving through the crystal lattice can cause a tiny vibration, which in turn creates a temporary positive charge that attracts a second electron. They form this little buddy system, and once paired up, they can move in perfect lockstep, gliding through the material without bumping into anything. They condense into a single collective quantum state. And this is their solution, written in the language of physics. Now don't worry about all the symbols. The beautiful thing about this equation is that it's the exact mathematical recipe that describes how those electron pairs form and how they all condense into one single frictionless quantum state. This was the key that finally unlocked the mystery, and it's what earned Bardeen his second Nobel Prize in 1972. Okay, so let's just take a breath here. We have 2 towering achievements: the transistor, a profoundly practical invention that built our classical computing world, and the BCS theory, a deeply abstract theory explaining a bizarre quantum state. They really seem like they belong to 2 completely different universes. So how on earth do they connect?
And this, for me, is the most fascinating part of Bardeen's entire story. Because it turns out his 2 discoveries aren't separate legacies at all. They are the 2 essential, absolutely non-negotiable components that make today's most powerful quantum computers possible. Let me show you how.
It really comes down to 2 key parts of a quantum computer. First, you've got the quantum core. The qubits themselves, the heart of the machine, are built from superconducting circuits, and they only function because of the physics of Cooper pairs that Bardeen explained with his BCS theory. But those qubits are useless on their own. To actually control them, to manipulate them, and read out the answers, you need a powerful classical computer system. And that control system is built from billions of his other invention, the transistor. It is just an incredible synthesis when you think about it. One discovery powers the quantum brain, and his other discovery powers the classical nervous system that controls it. Bardeen's life's work is literally the bridge that connects the classical and quantum worlds of computation. You know, John Bardeen's unique genius was this remarkable ability to be a master of two completely different domains. He could move so seamlessly between the abstract, theoretical world of quantum physics and the very practical, applied world of engineering, a technological revolution. Exactly. It's one thing to invent a device, and it's another to write a groundbreaking theory. He did both at the absolute highest level. His work really created a complete paradigm shift, inspiring the kind of interdisciplinary research that connects fundamental physics with computer engineering and computer science. That bridge he built is now a super highway for innovation.
And what's truly inspiring is that by all accounts, he was a quiet, humble, and unassuming person. He wasn't driven by fame, but by this deep, genuine curiosity. And because of that, he remains a model for how that kind of fundamental curiosity can lead to innovations that completely redefine what's possible for all of humanity.
It really makes you wonder, doesn't it? What will be the next breakthrough that connects a pure idea to a brand new reality? This explainer was based on the essay John Bardeen, Doppelter Nobel Prize der Physik by Jörg Oeschnabat. We hope you enjoyed this quantum deep dive. For more, please visit schnippet.de. Goodbye.
Schnepat.de is a private project by Jörg Oeschnabat dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.